Hello everyone. This is the second worksheet on chapter 16, which is on ANOVA testing. Now, the first question in this worksheet, again, I worked out completely in my lecture PowerPoint slides on chapter 16. So you may want to view that if you need an explanation, but you should be able to work it out yourself for some practice, right? So I'm going to work out the next question here, which is also on ANOVA testing. But since I worked out the previous problem, instead of repeating it on the worksheet, let's work on the next problem, the second problem. And we will do this up to finding the F statistics. All right. So here it says below is provided data from independent simple random samples from several populations. In each case, determine the given matrix. All right. So there are 3 samples from 3 populations. All right. So each of these samples come from 3 different populations. Let me pull out my pen here. Right, so this is going to be population 1, population 2, and population 3. So we will be comparing the means of 3 populations. All right, now the values given to us for sample 1, there are only 2 values, 1 and 9. For sample 2, it's 10, 4, 8, 6, 2. Therefore 5 values, and for sample 3 there are 3 values. So this is kind of a simple problem just for practice of calculating the F. Now they've provided us the individual data points, but we need to find the sample means for each of these samples and also find the overall mean, because remember the formula for SSTR, right? The formula, let me just write it down. Oh, well, it's written here anyway. So the formula for SSTR is sigma n sub j times x bar sub j, which represents each of these individual sample means, minus the overall mean. So to work this calculation, to work this formula, we will need to know the individual sample sizes, we will need to find the individual means, and we will need to know what the overall mean is, and then we'll work through this table step by step. Okay, so let's go about it. First, I'm going to find my n values and then my individual sample mean values. So here we have 9 plus, first of all, n is going to be 2 because we have 2 values in our data points. And then for sample 2, we have 5 for n. And then for sample 3, we have 3 values, right? Now, to find the mean goes with the formula sigma x divided by n, right? So to find x bar sub 1, just add up these values. 9 plus 1 is 10, right? That's our sigma x. Let me just write it up here. Sigma x is 10. 10 divided by 2 is going to be 5. 5 is the sample mean for the first sample. Then for the second sample, let's work it the same way. Sigma x is going to be 10 plus 4. It's going to be 30, right? 10 plus 10 and 6 plus 4, 10, so 30. So let's write here quickly, sigma x equals 30, and 30 divided by 5 is 6. And then for the third sample, 10 plus 16 plus 4 is again 30. So sigma x for sample 3 is also 30, and 30 divided by n, or 30 divided by 3 in this case, is 10. So these are our individual sample means. However, we also need to calculate the overall mean. That means the mean of all these values put together. Now, you can do it 2 ways. You can either do 1 plus 9 plus 10 plus 4 plus 8, add up all these individual values and then divide it by the overall sample size, which is 5 plus 3 plus 2, 10. All right, but I will also show you the other way, because sometimes in the tests and exams, they do not give you the individual values. Instead, they just give you the sample size and the sample means. How would you calculate the overall means if you're just given the sample means and the sample sizes? Well, this is how you work it. All right, the overall mean X bar is going to be calculated as n sub 1, so let's do it here, n sub 1 times x bar sub 1 plus n sub 2 times x bar sub 2 plus n sub 3 times x bar sub 3 divided by n. All right, so what you're doing is you are finding the sum of each sample by multiplying the sample mean by the sample size for that sample. All right, which should give you, when you do n sub 1 times x bar sub 1, it should give you these values 10, 30, and 30. Let's do that here. We have n sub 1 is 2 times x sub bar sub 1 is 5 plus 5 times 6, right? 5 times 6 plus 3 times 10, all right, divided by the total sample size n is 2 plus 5 plus 3, which is 10. So you're going to get an x bar value of 70, all right? 10 plus 30 is 70 divided by 10. Our x bar is going to be, the overall mean is, sample mean is going to be 7, and that is going to be the value of the overall mean. So keep in mind how to do this calculation, because I can guarantee you that in one of the tests on this chapter, you will not be given the individual values. Not necessarily you will be given the individual values. Instead, you may be given just a summarized value of the sample means and the sample sizes, and you will have to calculate your overall mean using this data instead of these individual data points. All right. All right, so now we are going to find our SSTR, which we need to find MSTR later on. Keep in mind our F value goes with this formula, as this formula. Let me write it down on the side. F equals MSTR over MSE. All right, and then to find MSTR, we need to find SSTR, or treatment sum of squares, divided by k minus 1. And for MSE, we need to use this formula, error sum of squares, or SSE over n minus k. So the next exercise is to find SSTR. Again, using this table, just list your sample sizes first. So I'm going to write here sample 1 had a sample size of 2, then 5, and 3. And the means that we just calculated were 5, 6, and 10. And in the next column, we have to subtract the overall means from the individual sample mean. So the overall mean was 7. So 5 minus 7 is -2. 6 minus 7 is -1, and 10 minus 7 is a +3. In the next column, you're squaring everything. So -2 squared is a 4, -1 squared is a 1, and 3 squared is a 9. And in the final column, you multiply each of these values in the previous column by their respective sample sizes n. So 4 times 2 is 8. 5 times 1 is 5. And 9 times 3 is 27. Sum them up, and you should get a value of 40. Right? 8 plus 5, 13, plus 27 is 40. So sigma is equal to 40, which is our SSTR. So now that we know our SSTR, we can go ahead and find our MSTR. MSTR is SSTR over K minus 1. K equals 3 because we are comparing 3 populations. So K minus 1 will be equal to 2. SSTR, let's plug in the values here. 40 divided by 3 minus 1 is 2, so it's going to be 20. All right, so that's our MSTR value. Let's hold on to it for now, and we are going to find next our SSE, or the error sum of squares, which goes by the formula sigma n sub j minus 1 times s sub j squared. Again, s sub j squared, remember, is the variance. And what is the variance? Is the standard deviation squared. Now, for this problem, you will need to find the standard deviations yourself. You can use your calculators, or you can do it by hand using the formula of standard deviation. However, I'm just going to give you the standard deviation values, or the variance values. Now, if in the test you may be given either the variance values of the variance or the values of the standard deviation. Please pay special attention and check what the question is giving you. If they've given you the standard deviation values, you have to square it in this table, all right? Because variance is s sub j squared. If you just use the standard deviation values, you'll get a wrong calculation, all right? So keep that in mind, whether you have been provided the standard deviation values or the variance values. If it says s squared, the variance values, you can just write them as given. But if it is the standard deviation, just the s values they've given to you, have to square them. So be mindful of that. So let's work through this table here. We know our sample size was 2, 5, and 3. So just write that down here, 2, 5, and 3. The variance, let me just give you the variance, 32.04, 9.99, and 36.00. Okay, these are the variance that I calculated and got. The next column is n sub j minus 1. So just subtract 1 from each of these sample sizes. So 2 minus 1 is 1, 5 minus 1 is 4, and 3 minus 1 is 2. And now just multiply the variance with the n sub j minus 1 value. So this third column and the fourth column should be multiplied and put in the final, in the last column. So we are going to have 32.04, and then 9.99 times 4 is almost 40. So I'll write 39.96, and 36 times 2 is 72.00. So add them up, sum them up for the SSE value, and you should get a value of 144.00, and that's your SSE. All right, that's your error sum of squares. So I'm going to write that value here for SSE, 144. Did I write the SSTR value somewhere up there? That was 40, right? 40. Okay, so let's move on. So for MSE, it's SSE over n minus k. Keep in mind, n is equal to 10. We use the value of n in calculating our overall sample mean x bar. So n is 10 and k is 3. So 10 minus k, 3 is going to be 7. SSE being 144 divided by 10 minus 3 is 144 divided by 7 is 20.57. 20.57, that's our MSE value. And once we have our MSE value, just plug in those values for MSTR and MSE into the formula. So that was 20 divided by 20.57. So we are coming up with a very small F value, F statistic value of 0.97. All right, and then you can go ahead and perform a hypothesis test that the question will ask you to perform. at the 5% significance level. But keep in mind, the test is always going to be a right tail test. F distributions are right skewed distributions, right skewed curves, therefore always right tail test. All right, right tail test, and you will be to find the critical value. All right, I'm just giving you some tips here. I'm not going to do the entire test, hypothesis test, but just keep in mind these points. If you were to do the test, then make sure you're doing a right tail test, and that's the only test possible with the F distribution. And the second one is to find your critical value F of alpha. The DF calculation, DF is numerator minus numerator comma denominator. So n is going to be calculated as, the numerator is k minus 1. That's the formula. So that's 2 in this case. This is going to be 2. And then a denominator is going to be calculated using the formula n minus k, which in this case is 7. All right. This is the denominator df. All right, so that completes this worksheet. Again, like I said, if you want to solve the first question and need to look at a solution, then please watch the lecture video. It's solved there. I've explained the problem over there and its solution.